Good day, dear students. I welcome you back to the lesson summary of the third term, the continuation. Now, in this unit, we'll be talking about the three-dimensional shapes. Three-dimensional shapes, as we also call it, the solid shape, is a shape which has three measurements of length, breadth, and height. We shall be talking about the volumes of various kinds of three-dimensional figures, of which the unit of measuring volume of any substance is in cubic meters, which we write in abbreviation meter cube, or cubic centimeters, which we write as centimeter cube. They have an inside and outside. So three-dimensional shapes have an inside and outside, unlike the plane shapes, which deals with the flat surface of that particular figure. But in this type of shape, we are interested in the inside of the shape and outside of it. So examples of three-dimensional shapes are cube, cuboid, cone, cylinder, prism, tetrahedron, sphere, pyramid, and so on. So I'll be showing you the pictures of these three-dimensional shapes. Now let's have a look at the pictures of these three-dimensional shapes, which we also call the solid shapes. This very one is called a cylinder. It looked like the oat milk. Alright, we call it a cylinder. It has two circular surfaces with a radius on each of them. Then the height is indicated from beneath the shape towards the top of it. Now we'll also look at the cube here, a cuboid I mean to say. This one is a cuboid, which has the measurement of length, width, and height. Alright, so and we also have the cube. Both of them look alike. Yeah, this one looks like our usual Maggi cube or sugar cube, whereas this one looks like a matchbox. Right, then this one is called the pyramid. Then here we have the cone, which looks like a titled man's cap. Then we have a triangular prism, tetrahedron, and the sphere. You know, the earth looks like this. This is just the shape of the earth, because we say that the earth is spherical in shape. So these are some of the examples of three-dimensional figures that we have here. It doesn't end here. We have so many other ones. Now let's proceed by identifying the properties of these three-dimensional figures. The first here, properties of pyramid. 1. It has 5 faces. And among the 5 faces of these pyramid, we have 4 triangles among them and 1 rectangle. As you can see, you have a triangle here, 1, 2, 3, and 4. So 4 triangles, and the base of it is a rectangular shape. So that is why we say that it has 5 faces, and those 5 faces are made up of 4 triangles and 1 rectangle. Now it has 8 edges. You can see the edges, the straight lines are the edges of this shape. They are 8 in number. Let's count them: 1, 2, 3, 4, then 5, 6, 7, and finally 8. So there are 8 edges in a pyramid, triangular pyramid. Then we also have this one as one of the properties. It has 5 vertices. That means it has 5 sharp points on it. You can see the sharp points here. So how many are there? There are 5. We'll start from here: 1, 2, 3, 4, 5. So they have 5 vertices. Now properties of cone. Properties of cone. You can see the shape of a cone here. It has one circular face here. So the first one we have here, it has one curved surface. That means it has one round surface. That's exactly what we mean by one curved surface. Then 2, it has one circular face. You can see the circular face here. Alright, then number 3, it has one edge. That's the circular edge, just one edge. Then it has one vertex, that is to say it has one sharp point. As you can see here, only one vertex. Now let's move to the next one. This is a cylinder. Alright, so the first property of a cylinder, it has one curved surface, just like that of a pyramid. So one curved surface, just round this shape, one curved surface. Then 2, it has 2 flat circular faces. You can see a circular face here and also another circular face here. Then number 3, it has 2 circular edges. So you can see the edge here, that's one circular edge. Then this one is another circular edge. So how many are there? 2 circular edges. Then finally, it has no vertex. You can see we don't have any sharp points in a cylinder. Alright, so let's quickly move to the next property. Alright, so the properties of a triangular prism. We equally have a rectangular block prism, but now we are more interested in discussing triangular prism. So properties of triangular prism. 1, it has 6 vertices, that is to say it has 6 sharp points. You can see them: 1, 2, 3, 4, 5, 6. So 6 vertices. It has 9 edges. You can see 1, 2, 3, then another one here, 4, 5, 6, then 7, then this one 8, 9, and finally, oh, that's 9 in number. That's 9 in number. So that is to say this one, 1, 2, 3, 4, 5, 6, 7, 8, then finally what? 9. Alright, so the next one, it has 5 faces. You can see the triangular face here, 1, another triangular face here, 2, then the one facing this side, 3, the one at the other side, 4, and finally the one at the bottom, 5. So it has 5 faces, and among these 5 faces, it is made up of 2 triangles. You can see a triangle here and another triangle here, and 3 rectangles. You can see this one is the shape of a rectangle, another one behind it, and the one that is lying flat on the floor. So it has 5 faces, and those 5 faces are made up of 2 triangles and 3 rectangles. Let's quickly move to the volume of cube and cuboids. From here we shall be looking at the properties of cube and cuboid, and you can see both of them are they have 6 faces, they have 8 vertices, and also 12 edges. But what can we say is the difference between these two shapes? This one is a cube, while this one is a cuboid. What is the actual difference between a cube and a cuboid? When you look at it very closely, you find out that this one, their faces are identical. That is to say, their faces look alike and they are equal. So therefore we can say that it has 6 square faces, because you know a square has all the 4 sides equal. So you can see all the shapes are equal in measure. So it has 6 square faces. That is how we are to qualify this. Alright, so that's what distinguished it from that of a cuboid. A cuboid has 6 faces, but what type of faces? Rectangular faces, because their faces look like a rectangle, whereas the faces of this one looks like what? A square. So a cuboid has 6 rectangular faces, while a cube has 6 square faces. That is just the major difference between the two. Every other thing is the same. They have 8 vertices and 12 edges. You can see the edges, these lines, 2, 3, 4, then 5, 6, 7, 8, 9, then behind it 10, 11, then 12. So it has 12 edges. So we can outline it in this form. That is by saying that a cube has 6 square faces. Okay, that is one. It has 8 vertices. I'm using just the initial to represent it. And finally, it has 12 edges. So it is quite the same language as for that of a cuboid, but what distinguishes both of them is that a square, just like a cube, just like we said before, has 6 square faces, while a cuboid has 6 rectangular faces. But both of them share this one in common. That's 8 vertices, 8 sharp points, and 12 edges. Alright, so that's just the major properties of cube and cuboid. Now let's look at the volume of cube and cuboid. Just like we discussed earlier on, that it has 6 square faces. That is to say, each face is a square. Remember that a square has all its sides equal, meaning that each of the edges of this shape are equal. So in that sense, that is to say, this one is represented by length. Each of those sides are to be represented by what? Lengths. And remember that 3-dimensional figures has to do with the measurements, the shapes with 3 measurements. And what are these 3 measurements? That's the 3 measurements of length, of breadth, and height. But in the case of a cube, all the sides are equal. That's why we label them length, length, length. In some textbooks, you may see it as x, 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 depending on what one decides to name it. Then the formula for finding the volume of a cube is length cubed. That is to say, you multiply each of these lengths. Length cubed, which means length times length times length. That is the formula for calculating the volume of a cube. Now let's look at the formula for calculating the volume of a cuboid. The formula for calculating the volume of a cuboid is length times width times height. That determines the volume of this particular shape. Now let's look at some examples here. We have 2 examples here. The volume of cube and cuboid. This question says we should find the volumes of each of these shapes, of which we already know that this one is a cube. Remember that a cube has all its 3 dimensions as lengths. Alright, so if this side is 5 centimeter, that is to say, this side should as well be what? 5 centimeter. This side should as well be 5 centimeters. Alright, having this as 5 centimeters, 5 centimeters, 5 centimeters. Now, how do we find the volume of this shape? And remember that we are being given the length at 5 centimeter. In that sense, to find the volume is equal to, in place of length, we write the 5, which is the value given as the length of the cube. So we raise it to the power of 3, just like the length is being raised to the power of 3. What does that mean? It means 5 times 5 times 5 into 3 places. Now 5 times 5 is 25. 25 times 5 will give us 125. Then for that of a cuboid, we multiply out the 3 dimensions. And what are the 3 dimensions? That is the 3 dimensions of width, length, and the height. Alright, so that's exactly what we have here. That is why we say the length, which is 6, times the width, which is 3, times the height, which is what? 5. 6 times 3 will give us 18. Then 18 times 5 will give us 90 as the value, 90 centimeter cube. Don't forget to write the unit of that particular shape, or the unit of volume. Alright, so let's look at the word problems relating to volumes of 3-dimensional shapes. We have the first question here. Find the length of a box whose volume is 60 meter cube. Find the length of a box whose volume is 6 meter cube, with the width and the height measuring 4 meters and 5 meters respectively. So in this case, we are being given the volume of that particular box, and at the same time we are being given the width and also the height as 4 and 5 respectively. Alright, so you can see what is being given to us in this question. We are being given the volume of that particular box, and when you look at it very well, you find out that this box, we are asked to find the length, we are being given the width, and we are being given the height. That is to say, we are talking about a cuboid, because a cuboid is what presents us with some of these values in question, just like we have it in this formula. As you can see, the length, the width, and the height. So once you have a question that has to do with the length, volume is given, the width is involved, and the height is involved, then you are talking about the volume of a cuboid. Alright, so the volume is given to us as 60 meter cube, the width is given as 4 meters, and the height is given as 5 meters. We are looking for the length because they said we should find the length. Alright, so we are going to make use of the volume of that box. And what is the name of that box? A cuboid. Alright, so the volume of a cuboid is equal to length times width times height. Alright, so in this question the volume is given, so in place of the volume we write 60 equal to, sorry that I'm representing all this with two equal signs. It's supposed to be one equal sign there. So the volume, which is being given to us as 60, equal to, then the length, we have it as what we are looking for, then times the width is being given to us as 4, that's what we have here, times the height, which is being given to us as what, 5. So that's exactly what we have here. So you substitute the values here, then we can now multiply through here. So we have our 60 equal to length times 4 will give us 4 lengths. Then 4 lengths times 5 will give us 20 lengths. You can as well multiply this way by saying 5 times 4, 20. Then 20 times L, 20L. So what we do next, we divide both sides by the coefficients of what? The length. And the coefficients here is what? 20. So we multiply both sides, divide both sides by 20. And when we do that, 20 will cancel out 20 from this end. So this 20 will cancel out this very 20 here. We are left with L. Then 0 will cancel out 0. Then 6 divided by 2 rather, will give us what? 3. That is why we have it as 60 divided by 20. That will give us 3 meters as our answer. Sometimes the question can be thrown in a reverse way. That is to say, they may ask you, find the volume of a box measuring 4 meter. They can put it this way, 4 meter by, they will just use the word by, the next one, 4 meter by 5 meter, then as well as by, and that will be the last one we have here, by 3 meters, as we have as our answer. So they can put the question in this form. So whenever you see anything, this by this by this, you multiply all of them together. That gives you the volume of that particular shape. Alright, so but in the case of our question here, we are being given the that is the width, we are being given the height, and we are asked to find the length, and we got the length to be what? 3 meters, just like we did it in this question. Alright, so let me just repeat it again so that you get to understand it better. So in this question, the volume is being given to us, then the width is given in the question as 4 meters, and the height is given as 5 meters, and we are asked to find the length. Alright, so the formula for finding the volume of a cuboid is volume equal to length times width times height. So we are being given the volume as 60 equal to L is what we are looking for, times the width is being given to us as 4, times 5 is being given to us as H is being given to us as 5, which is the height. Now we now multiply through, we have our 60 equal sign, 5 times 4 will give us 20, 20 times L will give us 20L. Dividing both sides by the coefficients of L, and the coefficients of L is 20. Divide this by 20, then also divide this one by 20. 20 will cancel out 20 here, we are left with L. Then 60 divided by 20 will give us 3. That is by cancelling 0, cancel 0. Then 6 divided by 2 will give us 3. And that is solution to this particular one. Let's quickly look at another one. Here we have a question: find the length of a cube whose volume is 27 meter cube. We are looking for the length of a cube. This time around they mentioned the shape. The shape in question is what? A cube. And what of a cube? That is a volume of a cube. So we are going to make use of the formula for finding the volume of a cube. But in this question, the cube is being given to us, the volume is being given to us as 27 meter cube. That's exactly what we have here, and we are asked to find the length. Alright, so the volume will now be equal to length cubed, or you already know this as the formula, which means length times length times length. Alright, so in the question, the volume is being given to us, so in place of this volume, we write 27 equal to length cubed. So just remember what we did in the area. When you have something squared, what we normally do, we find the square root of both sides. But now that we have cubed here, so we are going to find the cube root of both sides. And when we find the cube root of both sides, this cube root will cancel this cube here. Then we also have cube root at this side because we are applying it on both sides. So when that is done, the cube you have here will cancel the cube root we have here will cancel the cube. Alright, so we are now being left with what? L. So we now have L equal to the cube root of 27. It's just like asking, which number will you multiply to itself 3 times to give you 27? That number is 3. Because when you say 3 times 3 times 3, it will give us 27. Therefore, the cube root of 27 is 3 meters. That is exactly how to solve this question. Let me take it again. The volume is giving us 27 meter cube. The length is what we are looking for. The volume of a cube is volume equal to length cubed. Then in place of volume we write 27 because that's exactly what is being given to us here. Equal to the length is what we are looking for. So length cubed, we'll bring it down here. So what do we do to eliminate this cube here? Because what we are asked to find is the length. We apply cube root on both sides. If what we have here is square, we apply square root on both sides, just like we did in the case of an area. So we apply cube root on both sides. So this cube root will cancel this cube. Then the cube root of 27 is what we have here. Length is equal to cube root of 27. And cube root of 27 is 3, because 3 times 3 times 3. The number you multiply 3 times to itself, and it will give you that number that you are looking for is cube root. That is will be the full solution to that particular question. So the cube root of 27 is 3. Because 3 times 3 times 3 into 3 places will give us what? 27. So that's the solution to that. There are some other formulas for calculating the volume of other 3-dimensional shapes. Like the volume of a cylinder, this is the formula, that's pi r square h. The volume of a cone, that is 1 over 3 pi r square h. The volume of a sphere, that is 4 over 3 pi r cubed. So these are the formulas. You have to just know the formula. By the time you get to GS3, you'll be making use of these formulas in doing calculations. Now let's quickly move to the next outline. Now we'll be talking about angles. What is an angle? Angle is simply defined as the measure of movement, measure of rotation, as the case may be. An angle is simply defined as the measure of what? Rotation. What do we mean by this? So let's take, for instance, this is your house and this is your school. You are going to your school, you move from your house all the way. When you reach this junction, you now divert to your school. You start moving back to your school, you now reach your school. There is a lot of turning that took place here. That moving from your house, reaching this junction, then you diverted. You have been able to make an angle here. The rotation made here defines the angle that you have moved from your school or back home, or from your home to the school. Alright, so that is to say that angle is the measure of what? Rotation. It can also be defined as the figure formed when two rays, the rays we are talking about is these two lines, two rays meeting at a common point. As for this one, they met at the common point here, that to create that particular angle in question. It is formed when two straight lines meet, just like we indicated here. Angles are measured in degrees and radians. But most importantly, at your stage now, we'll be recognizing the measurement of angle in degrees. Alright, so that's the unit of an angle, and we represent it with an upward circular, shape like this, like we have it in 90 degree here. Now let's begin by looking at the types of angles. What are the types of angles? The first one we have here, acute angle. An acute angle is an angle that is less than 90 degree. Any angle that is less than 90 degree, that's smaller than 90 degree, is called an acute what? Angle. Example of an acute angle include 1 degree. 1 degree is an acute angle because it is smaller than 90 degree. That's what we mean by less than 90 degree. 20 degrees is an acute angle. 30 degrees is an acute angle. 35 degrees is an acute angle. 57 degrees is an acute angle. 53 degrees is an acute angle. 81 degrees is an acute angle. Even 89 degree is an acute angle because it is still less than 90 degree. So any angle less than 90 degree is called an acute angle. Now look at the diagram here. You can see it bends, or the bending of the rotation of the angle is smaller than that of 90 degree. You recall that 90 degree is the one that gives us a square corner like this. You can see how it looks, but this one bends. That is to say, it is quite smaller than that. It is quite smaller than what we have here, the bending. So the angle begins from here to here, whereas that of 90 degrees from here all the way to this side. So that is to say, this angle is called what? An acute angle, because it is less than 90 degree. Now let's quickly look at other types of angles. Now we have right angle, just like I indicated previously. This is what we call the right angle, and right angles are exactly equal to what? 90 degree. Alright, so we are going to be making use of this in our calculation. So you might be seeing something of this nature, whereby a line will be drawn, you'll be given a particular angle here, and you'll be asked to find the other end of it. So once you see an angle of this inclination, that is to say you are talking about right angle, and right angles are equal to what? 90 degree. So obtuse angle, this is an angle greater than 90 degree but less than 180 degree. The condition is that it must be greater than 90. Then another condition is that it must be less than 180 degree. Once that is established, the angle in question is called an obtuse angle. Like looking at this diagram, you can see the diagram of an obtuse angle, which means it becomes wider than that of 90 degree. It's just like having an extension like this, and the rotation will now be measured all the way like this. So there is more extension this time around, and such angle, as you can see from here, is called what? An obtuse angle. Examples of an obtuse angle: 91 degree is an obtuse angle. The reason is because 91 is greater than 90 but not up to 180. That means it's less than 180 degree. 120 is an obtuse angle. 158 is an obtuse angle. 170 is an obtuse angle. 179 is an obtuse angle, in as much as it is bigger than 90 degree but less than 180 degree. Such angle is called what? An obtuse angle. Then angle on a straight line. You can see the straight line here. This angle makes a semicircle here. You can see the curve here. Makes a semicircle. It looks quite like your protractor. The protractor you have in your math set, which ranges from 0 to 180. Alright, so angle on a straight line. Any angle, the angles inclined on a straight line is always equal to 180 degree. So angle on a straight line is any angle that is equal to 180 degree. That's the angle we call what? Straight line angle, or angle on a straight line. Take note of this one. We are going to be making use of it in our calculation. Then reflex angle. A reflex angle, there are two conditions here. One, a reflex angle is an angle that is greater than 180. It must be greater than 180 but less than 360 degree. So the angle must be greater than 180 and must be less than 360 for you to call it what? A reflex angle. 181 degree is a reflex angle. The reason being that 181 is greater than 180 but less than 360. 189, 200, 270 degree, 335 degree, all are called what? A reflex angle. What about 359 Is it a reflex angle? 359. Is it a reflex angle? Yes. I believe somebody must have gotten the answer there. Yes, it is a reflex angle. The reason being that 359 is greater than 180, but less than 360. That makes it what? A reflex angle. Now let's quickly go to the next other types. Here we have angle at a point, angle at a point. So you can see it's no longer angle on a straight line, even though we have a straight line here. So angle between here and here is angle on a straight line. Then we equally have another angle on a straight line, that is from here to this other straight line. That's another angle on a straight line. So remember that angle on a straight line is equal to 180 degree, right? So you have angle on a straight line here, one, another angle on a straight line here, making it a circle. So angle in a complete circle is equal to 360 degree. So I will call it what? Angle at a point, angle at a common rotation. You can see here it goes round. So from here to here on a straight line is 180. Then from here to here also on a straight line is 180. So 180 plus 180, that will give you 360 degrees. So angle at a point that makes a complete circle is equal to what? 360 degrees. That means the angle you have here A plus angle you have here B plus angle you have here C plus angle you have here D, all equal to what? 360 degree. Take note of this. We are going to make use of it in our calculation. Then complementary angle. Complementary angle. These are the two angles that sum up to 90 degree. What do you mean by this? The two angles that you add together to give you 90 degree is called a complementary angle. Once you add the two angles together and they gives you 90 degree, then what you are talking about is a complementary angle. You can always remember it this way: complementary 90, supplementary 180. So complementary angle are the two angles that sum up to what? 90 degree, like you have it here. Y plus x is equal to 90. We are going to be seeing something like this in our calculation. Now we have the final one here: supplementary angles. Supplementary angles are the two angles you add up together to give you what? 180 degree. For instance, for this particular one, what is the complementary angle of 40 degree? What is the complementary angle? They can say, what is the complement of 40 degree? The complementary angle of 40 degree is actually what? 50 degree. Do you know why? Because when you add 50 to 40, it will give you 90. So both of them are said to be what? Complementary angle. So now let me ask you a question. What is the complementary angle of 60 degree? I know somebody must have gotten the answer there. The complementary angle of 60 degree is 30 degree, because when you add 30 to 60, that will give us 90 degree. Now let me ask the final question. I hope you can get this one quite smartly. Then what is the complementary angle of 32 degree? Can you answer the question? What will you add to 32 so that it will give us 90? Try. Okay, now somebody must have gotten the answer, and the answer to this question is 58 degree. 58 degree, because when you add 32 plus 58, that will give us what? 90 degree. That's exactly what we mean by complementary angle. Now let me ask you for this particular one, what is the supplementary angle of 120 degree? What is the supplementary angle of 120 degree? That is to say, what will you add to 120 so that it will give you 180 degree? And that answer is what? 60 degree, because 120 plus 60, that will give us 180 degree. So once you add up two angles and they give you 180 degree, you call it what? Supplementary angle. But once you add two angles together and they give you 90 degree, you call it what? Complementary angle. So we are going to be making use of that in our calculations. Now let's begin by doing some calculations on angles. Here we have some questions here. Find the values of the unknown angles below. You can see, can you tell me the name of this angle? Can someone guess what the name of the angle is? Yeah, I believe somebody must have gotten the answer. The type of angle we have here is what? Angle on a straight line. If you recall, we have an angle which we drew like this by having something of this nature. We call it angle on a straight line. You can see that straight line, and you can see the inclination or the rotation of the angle on this straight line. So angle on a straight line is equal to what? 180 degree. I hope here is quite clear. Then as for this one, who can tell us the name of this angle? Oh, I believe somebody must have gotten it there. So the name of this angle is called right angle. And right angles are equal to what? 90 degree. So this is a right angle. So you see how we'll be applying this in our calculation. Remember, this is angle on a straight line, and angle on a straight line is equal to what? 180 degree. Well done for getting the answer. Then for this one, this is called what? Right angle. Now I want to ask you a question. Right angle is equal to what? 90 degree. Wonderful. Somebody must have gotten the answer there. Then for this particular one, what do we call it? What did you say? Wow. Wonderful. This is angle at a point. You must have gotten the answer. A round of applause for yourself. Then angle at a point is equal to what? I know somebody must have gotten the answer there. And the answer is what? 360 degree. Angle at a point is equal to 360 degree. Then this one is equally angle on a straight line. Now let's look at the solutions to these questions. For the first one, here we have angle on a straight line, and the angles we have there are angle 135 degree and angle Y. So what do we say angle on a straight line is equal to? Angle on a straight line we say is equal to what? 180 degree. What it means is that we add everything we have here and say equal to 180. The reason is because angle on a straight line is equal to 180. So we add everything we have here and say equal to what? 180 degree. The reason we say equal to 180 is because we are talking about angle on a straight line. Whenever you're talking about angle on a straight line, add everything you see in that angle and say equal to what? 180 degree. Now let's solve this. For this particular equation, then we have to collect like terms. Then y is already here. Then plus 135 moving to this side become minus 135. So we now have it as y is equal to 180 minus 135, and the answer will be what? 45. Then for this one, what do we call this angle? This is right angle, and right angle is equal to what? 90 degree. So what are the angles we have here? We have angle y and angle 32. Remember that right angle is equal to what? 90 degree. That means we add everything we see here and say equal to 90 degree. Why did we say equal to 90 degree? Because we are talking about right angle, and right angles are equal to 190 degree, I mean to say. So you add everything you have here, that is y plus 32 degree is equal to 90 degree. Now let's now collect like terms. Plus 32 moving to this side becomes minus 32. So we now have it as y is equal to 90 degree minus 32 degree. That will give us what? 58 degree, and that is the answer to that particular one. Now let's quickly move to the other solutions. Here we have angle at a point, and we already know that angle at a point is equal to what? 360 degree. That means we have to add everything we have here and say equal to 360 degree. The reason being that we're talking about angle at a point. So for here we now say 90 degree plus 85 degree plus 75 degree plus a is equal to 360 degree. We added all these values here and say equal to 360 degree. Can you tell me the reason why we say equal to 360 degree? Yeah, I believe somebody must have gotten the answer there. The reason is because it is what? Angle at a point, and angle at a point is equal to what? 360 degree. Now let's now solve this. Having said 90 plus 85 plus 75 plus a equal to 360 degree. Now collecting like terms, we add all this together, and that will give us 250 degree plus a is equal to 360 degree. Now collecting like terms, a, then this one moving to the other side, it is plus here. When it comes to this side, become minus. A is equal to 360 minus 250, and the answer will now be equal to 110 degree. Then the final one we have here, the final one of this, we have 3x degree, 2x degree, and these are the angles we have on a straight line. So angle on a straight line is equal to what? 180 degree. That is to say, we add everything we have here and say equal to 180 degree, because this is angle on a straight line. That is what? 180 degree angle. Now 3x plus 2x is equal to 180 degree. Then 3x plus 2x, that will give us 5x, is equal to what? 180 degree. Can you tell me why is equal to 180 degree? The reason is because we are talking about angle on a straight line. Now we divide both sides by the coefficients of what? X. And the coefficients of x here is what? 5. We divide this one by 5 and also divide this one by 5. Dividing both sides by 5. 5 cancel 5. Then we have x is equal to 180 divided by 5. Then 5 divide itself 1. 5 divide 18. That will give us 3 remainder 3. So putting that 3 in front of this 0, that becomes 30. Then 5 divide 30 will give us what? 6. That's why we have our answer as 36 degree here. Alright, so let's quickly move to the next outline. Find the missing angles below. Here we have a triangle. You already know that the sum of angles in a triangle is equal to 180 degree, right? So 82 degree plus 55 degree plus x degree is equal to 180, because sum of the interior angles in a triangle is equal to 180 degree. Don't forget that. Any triangle at all, the sum of the inner angles, all the three angles you have there, is equal to 180 degree, because sum of the interior angles of any triangle is equal to 180 degrees. So all we need to do is to add all these things together and say equal to 180 degrees, because the sum of the angles in a triangle is equal to 180 degrees. So we can now say 82 plus 55 plus x is equal to 180. Then 82 plus 55 will give us 137 plus x is equal to 180 degrees. Then collecting like terms, we have x, then 180, then plus 137 going to this side become minus 137. Then x is equal to 180 minus 137. That will give us 43 degree as our answer. Now when you look at this one, what type of triangle is this? Can you answer the question? What type of triangle is this? This is what we call an isosceles triangle. Why do we call it an isosceles triangle? Because two sides are equal. Only two sides are equal in an isosceles triangle. Can you still remember what we said about the properties of an isosceles triangle? We said that the base angles are equal, the bottom angles are equal. So since the bottom angle here is A, therefore this side should also be what? A, because the base angles are equal. Alright, so having said that, we can now add all the angles we have inside this triangle and say is equal to 180 degree, because the total interior angle of any triangle is equal to 180 degree. You remember why we also have A here, because this is an isosceles triangle and the base angles of an isosceles triangle are equal. If this place is A, then this place should also be what? A. Now we add everything and say equal to 180, because the total angle in the triangle is equal to 180. So we can now say A plus 70, as we have it here, is equal to 180. That is sum of angles in a triangle. A plus A will give us 2A plus 70 equal to 180. Then collecting like terms, plus 70 will move to this side, and when it goes to this side become minus. So we have 2A is equal to 180, then plus 70 going to this side become minus 70. Then we now have 2A is equal to 180 minus 70 will give us 110. What do we do next? We divide both sides by the coefficients of A, and the coefficients of A is what? 2. When we divide both sides by the coefficients of A, which is 2, the 2 we have here will cancel these 2. We are left with A is equal to 110 divided by 2 will give us what? 55 degree. And that is the answer to that question. Let's move to the final one we have here. You can see what we have here. There are two ways we can solve this question. Is either we use the interior angles in this triangle. You know that the total interior angle of any triangle is equal to 180. So we can say 50 plus 70 plus x equal to 180. Then find our x. Or we can use angle on a straight line. That is the first method we use here. We can use angle on a straight. Remember, this is a straight line, and there is an angle between this straight line here. We can form a semicircle here. So this is an angle on a straight line. Angle on a straight line. There's angle between this and this existing on a straight line. Angle on a straight line. An angle on a straight line is equal to 180 degree, meaning that x plus 120 will be equal to 180, because their angle form within this what straight line. So that's why we say 120 plus x is equal to 180, angle on a straight line. Then collecting line times x, 120 moving to the side become minus 120. X is equal to 180 minus 120. X will be equal to 60 degree. There is another way we can solve this. That is by using the total angle inside of a triangle. Okay, so we add everything here and say equal to 180 degree. Okay, so that's now 50 degree plus 70 degree plus x degree is equal to 180. That's exactly what we have here. That's sum of angles in a triangle. Then collecting line time, 50 plus 70 will give us 120 plus x is equal to what? 180. Then collecting line times, we have x here plus 120 going to the side become minus 120. X is equal to 180 minus 120. The answer will be what? 60. The same answer as we have it here. So you make use of any of these two methods during the exam, but don't use all for me. Just use one method and solve. Alright, so let's quickly move to other outline. This is another one here. This is a quadrilateral. That's four-sided what? Shape. Four-sided shape. So what we have here is M. What we have here is angle M. So we are looking for angle M. Okay? We are looking for angle M degree. So, and this is a quadrilateral four-sided shape. Remember what we said about four-sided shape? One of the properties of any quadrilateral is that the total angle in any four-sided shape is equal to 360 degree. 360 degree. Any four-sided shape, the total interior angle of any four-sided shape is equal to 360 degree. We call them quadrilaterals. So that means when we add all these things we have here, we say equal to 360 degree because it's a quadrilateral. That is 82 plus 113 plus 51 plus M equal to 360 degree, because that is total interior angle of any quadrilateral. Okay, so you can start with anyone. You can say 51 plus 103 plus 82 degree plus M equal to 360 degree, because that is the sum of angles in a quadrilateral. Then let's collect line time. This plus this, that's 82 plus 113 plus 51, that will give us 246 plus M is equal to 360. Now collecting line times, we have our M plus 246 moving to this side become minus 246. Then 360 minus 246, that will give us 114 as our answer, as you can see from here. That's option D. Now let's quickly move to the next last topic that we have for this term, which is statistics. Statistics is the process of collecting, organizing, and presenting data. Just imagine your mother telling you to go to the kitchen to count the number of plates that are washed and those ones that are not washed. When you get to the kitchen, you begin to isolate the ones that are washed and the ones that are not washed. You might come out to tell your mother that, Mommy, 5 plates are washed while 2 plates are not washed. But in other words, how many plates do we have there? That is 7, because 5 plates are washed, 2 plates are not washed. So the washed plates are 5 in number, 2 plates are not washed, the ones that are not washed. So when you look at this, that is exactly what we call statistics. You are taking the number of plates that are washed and the number of plates that are not washed. You are actually taking a statistics. In other words, taking census of things. That is exactly what we mean by this statistics. And when you are asked to go to the kitchen to name the ones that are washed and the ones that are not washed, then first thing you have to do is to collect your information, okay, by gathering the plates, the ones that are washed and those ones that are not washed, organizing them, putting the ones that are washed one side and the ones that are not washed another side. Then you now present the data before your mother by telling her that 5 are washed, 2 are not washed. That is just the concept of statistics. You may be asked by your form teacher to count the number of male students in your class and the number of female students in your class. You are actually doing statistics, taking census. So it also involves using the organized and presented data for the purpose of analyzing, planning, and predicting for future events. Now let's quickly move to presentation. That's a presentation of data, that in terms of tally and frequency table. How do we construct a frequency table? We have an example here. Example 1 says the scores of 30 students in maths tests are shown below. These are the scores some students scored in their mathematics test. Some are scoring 8, some are scoring 6, some are scoring 2, some are scoring 0, and so on. Now, we are going to present this information or data, I mean to say, prepare the tally and frequency table for the data that we have here. How do we do this? Remember, these are the scores of students in mathematics test. So the first thing you do, you write scores, then tally and frequency. You create it in a table. Then for you to get the data, collect the information together and present it before anybody that asks you to get that is information. So the first thing you do here, you underline these numbers according to the order of their magnitude. What do I mean by that? You start from the smallest number to the biggest number. Now, what is the smallest number among these scores? That is 0. You write 0. Followed by which other score? 2. You write 2. Followed by which other score? 4. We write 4. Followed by which other score? 6. We have 6. Followed by which other score? 8. We write 8 and 9. Now, having written the scores of these students, then we want to know the number of students that scored these marks. How many people score 0 here? So we are going to be counting it in terms of tally. In tally marks, when you count 1, that is a 1 stroke. What represents 2 is 2 strokes. What represents 3? 3 strokes. What represents 4? 4 strokes. Now, when you are counting 5, you count it as 1, 2, 3, 4. The fifth one, you strike through. That's how you write it. You don't write 5 like this. 1, 2, 3, 4, 5. No. The way you write is 1, 2, 3, 4, then 5. You strike through. That is how you draw tally marks. Alright, so let's now begin to count the values we have here. Now we are going to ask ourselves question. How many zeros do we have in this data? Let's count them. 1, 2, 3, 4. Oh, we have 4 zeros there. Then we cannot count it in our tally. 1, 2, 3, 4. That is this. You write it as a frequency. 4 as a figure. Now, how many 2's do we have here? 1, 2, 3, 4, 5, 6, 7, and 8. So 8 2's. So how do we count this? 1, 2, 3, 4, then 5, 6, 7, 8. So we have 8 in our frequency. How many 4's? 1, 2, 3, 4, and 5. So we have 5 4's. 1, 2, 3, 4, 5. That's this. Then 6 we have 5 at the same time. Then 8 we also have what? 5. Then 10 we have 1, 2, 3. So we have 3 there. Now we can total the frequency. That's 8 plus 4 will give us 12. 12 plus 5 will give us 17. 17 plus 5 will give us 22. 22 plus 5 will give us 27. 27 plus 3 will give us what? 30. That means 30 students took part in that test. Why? How many people score 0? 4 people. How many people score 2? 8 people. How many people score 4? 5 people, and so on. So this is how to present a tally and frequency table. Now this is the one you have to do. You have to do this one. Alright, you do it in your notebook. Alright, and submit while coming to school during our next lesson. Now here we have what we call the measure of central tendency. The measure of central tendency involves the calculations of mean, median, and mode. These are what we call the measures of central tendency. So we are going to be calculating the mean, median, and mode. So we have first question here. Calculate the mean or average. So another name for mean is what? Average of the following sets of numbers. So we are going to find the mean or average. Sometimes during the exam they can call it average or they can call it mean. They mean the same thing. So find the mean or the average of the following set of numbers. We are going to see the solution. Then here we'll ask, find the median of the following set of numbers. Find the median of the following set of numbers. Alright, so let's look at the solutions to these questions. The first one, mean. Mean means the sum of the numbers in the set you add all the numbers, then over the total number of occurrence of the set. That means how many times did the number appear? That's 1, 2, 3, 4, 5. So 5 times. We divide by 5. Remember what I said, you add all the numbers given in the question. These are the numbers given in the question. For you to find the mean of these numbers, you have to say 8 plus 12 plus 16 plus 18 plus 21 over how many? How many are they? 1, 2, 3, 4, 5. Then you say over 5. That's how to do it. That's exactly what I showcased here. You add all the numbers and divide it by total number of appearance or occurrence. 1, 2, 3, 4, 5. That's why we divided by 5. And when you add all this together, that will give us 5 over 5. And 75 divided by 5 will give us what? 15. Now median. Median is the middle number. But it's not just the middle number, because some people make mistakes. Whenever they ask you to find the median, you begin to locate the middle number immediately. No. Median is the middle number after you finish arranging those set of numbers in either ascending order or descending order. The first thing you do is to arrange the numbers in ascending order before you can now locate the middle number. So as far as this number is concerned, the smallest number here is 0, then followed by 1. How many ones do we have? 2. Now 1, we also have 1. How many 2s? 2. There are 3. 1, 2, 3. You write 3 of them. 1, 2, 3. That's it. 3 2s. Then how many 3s do we have here? 1, 2, 3. You write the 3 3s. Then finally 5. How many 5s? 2 5s. So you finish arranging it from the smallest to the biggest. Now we can locate the middle number. We begin to delete numbers from both ends. Let me delete 3 numbers here from the right, and also delete 3 numbers at the left. Now I begin to delete them 1 1. Delete 1 at the right, delete 1 at the left, delete 1 at the right, delete 1 at the left. What do I have left? I only have this number left at the middle. So this is the middle number, and this number is our median. So the median of this set of number is equal to 2. 2 is the median. I hope it's quite clear. Now let's look at the median of this set of numbers. There are 2 different kind of questions. So the median, you know, the first thing we have to do, we have to arrange in ascending order. Let's arrange them in ascending order, starting from 4. How many 4? 1, 7. 7 is the next. After 7, 11. After 11, 17. After 17, 19, 20. Then when you finish arranging them in ascending order, now we can now begin to look at the middle numbers. Delete 3 from the right, delete 3 from the left. Okay, sorry, I deleted more than 3 here. Let me start it again. Delete 3 from the right, delete 3 numbers from the left. Now let's take it one by one. Delete 1 from the right, 1 from the left. Recall that if I delete this one, then we have nothing again. So that means we have 2 numbers at the middle, because we cannot cancel this one, cancel this one. If you cancel this and cancel this, we have nothing, and we must have something at the middle. So we now have 2 numbers at the middle. Whenever you have 2 numbers appearing at the middle, the median will now be, you add the 2 numbers and divide it by 2. That is to say, you find the average of the 2 numbers. That's 19 plus 21 divided by 2. That's what we did here. So 19 plus 21 divided by 2. 19 plus 21 is 40 divided by 2. 40 divided by 2 give us 20. So the median of this is what? 20. Well done. I think we are moving ahead. Now let's look at mode and range. Number 4, find the mode of the following set of numbers. We have 15, 18, 14, 15, 13, 15, 10, 11. Then find the range of the following set of numbers. 5, 3, 7, 2, 1. Alright, so mode means the highest occurring number. That means the number that appear more than the others. When you look at the question here, which number appear more than the others here? That is 15. Because 15 appear 3 times. 1, 2, 3. While others are appearing once. So the answer to this question, the mode of this question is 15. Because 15 appear more than the others. I know somebody may be asking a question. What if we have a number that appear the same time? Okay, let's, for instance, we have 11 here, and we also have another one, 11 here. So in this case now, we now have 3 11, and we also have 3 15. So which one will now be our answer? Wow, that's a very good question. The 2 of them are answers. The answer to this question, if we have 3 11s here and 3 15s here. The answers will be what? 11 and 15. 11 is this lower order mode, while 15 is the higher order mode. But both of them are the answer in that case. Alright, so but in this case now, we are dealing with the one that has 15 appearing more than the others. Therefore, 15 is our answer. Then the range means the biggest number minus the smallest number. From among these numbers, which one is the biggest number? The biggest number is 7 minus the smallest number is what? 1. So 7 minus 1 will give us 6, and that is the answer to the question. Now let's look at the representation of data. Representation of data. We represent data in terms of charts. We have bar charts, we have a pie chart, we have histogram, and we have a pictogram, and so on. So let's represent this data on a bar chart. We are being given the scores 1, 2, 3, 4, 5, and the frequency are 4, 8, 9, 3, 6. They will give you this type of question in exam. If they give you such question, all you need to do is to draw a graph of both of them. Then you draw a vertical line here. The vertical line represents your frequency, while the horizontal line represents the score, okay, or that particular item mentioned. That's the horizontal. So we now begin to number this. We start by using the multiples of 2 here. You can actually use 1, 2, 3, 4, 5, 6, 7 until you get to this. Alright, so we have decided to use the multiples of 2 here as the scales. This place 2, 4, 6, 8, 10, and 12. That represents our frequency, the frequency that we have here. Okay, now this one represents the numbers. Number 1 of the score, number 2 score, number 3 score, number 4 score, and number 5 score. Now how do we draw this? Bar chart has spaces between them. Bar chart has spaces between each of the boxes, but histogram, as you can see here, has no spaces between them. They are very closely attached to each other. That is the one we call histogram. Alright, so but in a bar chart, let's now represent it for 1. How many frequency? 4. Then we have to draw the bar until we get to 4. This is 4 here. We have reached 4. We'll draw it. Okay, this is for 4. 2 is how many frequency? 8. We draw a box, that's the bar, from 2 reaching 8. This is 8. Then we equally complete the box. Sorry. Then you equally complete the box. That's moving like this. So 3 represent what frequency? 9. You can see 9. 9 will be between 8 and 10. 9 should be somewhere here. Because we have 8, then we should have 9 before 10. So that's why the frequency is drawn in this manner towards this place. Because that is 9 here. So we draw the box. Then 4 represents 2. As you can see, 3. As you can see here, 4 represents 3. And 3 is between 4 and 2. 3 should be somewhere here. 3 should be somewhere here. That should be the middle between 4 and 2. So when you locate this towards this angle, that will 4 will represent what? 3, as far as this one is concerned. Alright, then 5 represents 6. So 5, you draw it all the way to reaching 6 level. So that is how to draw a bar chart. Now finally, let's look at histogram. Histogram is like that of a bar chart, but the difference is that these ones are closely touching each other. As you can see from here, the score 4 is to 9. 9 is between 8 and 10, because after 8 you count 9. So this is it. 5 represents 5. So 5 is between 6 and 4. So 5 is here. Then 6 is also 5. 7 is also 5. And 8 is 6. That should be along here. So this is how to draw this. And this is where we'll be drawing the curtain for our lesson today. Have a wonderful day and bye. See you next time.